Why the transcript is translating different? Okay. Okay, okay guys, so for chapter 3, okay, so at least you have that idea, the basic idea, okay, on what is the common term that we usually use, and we will keep talk about it until end of this course. Okay, so for this chapter, last week, I think last week in general we talk about what is point of estimation, what is interval estimation, okay, and we clearly have seen that in terms of sampling on the population mean, because we are using a sampling distribution from the sample mean, okay, to estimate the population mean, okay. By estimating this, we will need to know what is their point and interval of estimation, and at the same time we have to know from the sample that we take, okay, we from the sample that we take, we aim to estimate the population mean, okay. And sometimes the sample could be, the number of size of your sample could be a large sample, okay, and in some cases it could be a small sample. So it actually depends back on what kind of variable that you plan to study to estimate the population mean, okay. So this is what we have learned last week, okay. So for today, we will touch on the estimation on the population proportion, which is actually similar, okay, but the only difference is actually one is taking the sample proportion, okay, and previously we talking about sample mean, we count the sample mean, okay. Just to highlight again the content, okay, so we have this kind of sample, okay, we are doing the procedure of estimation, okay, to estimate the whole population parameter, okay. So we so far we have some idea. I'm hoping that we already get some idea from what we want to estimate, okay, what are the procedure that involved, okay, and how we want to determine our samples that we want to search, okay. What are the sample that we're going to use, okay. Last time we talking about the point estimate, okay, and we also discussed about the interval estimate. If you still remember, when we under the topic of interval estimate, is actually measure what is our confidence level, what are the significant level, meaning that the error that we allow in our data collection, okay, to estimate the population, because we are taking a sample, okay, we have a certain confidence on the data sample that we have, okay, to estimate the population, okay. So these are the things that we did last week, okay, and I'm hoping that you still can get the idea on why there are critical value, what is actually the critical value, how this involves to apa tadi Azad said, standard normal curve, okay. So any terms that actually you think is actually important, when I do keep highlight in this in our lecture, please help to write in the chat box, okay. Because this kind of term, if you this is very crucial lah. Once macam ni kan, what is actually the separation, the value that separate between the red region and the blue region? It is called a critical value. Critical value that split into the error, the region, this region, okay, and the confidence level regions, okay. So if you have this kind of normal curve, okay, where they have two sides of the error, okay, meaning that the blue area here is the confidence level that based on the sample data that you use, okay, and this Z value is indicator of your critical value to split between the region that you allow the error and also the region where you accept where you are confident with your sample, okay. So there are few things here, few terms here: critical value, the alpha itself is the significant level, and the region, the interval that split between the left side of the critical value and the right side of the critical value, which actually give you the confidence level. Okay, confidence level, which is actually normally represented in percentage. Okay, confidence level percentage. And then because we allow certain error, so the error can be on the negative side or the positive side of this data. So this is how macam you are doing some testing or you are doing some sampling survey data. So you want to make some claim based on the data, based on the sample that you have. So but you have to give yourself what is your confidence level of your data. Oh, by the way, can someone write in the chat box what is the normal confidence level that is normally used in any statistic in any statistic analysis? Last week I did mention about this. What is the normal confidence level percentage that we that commonly used, okay, in fact in any statistic tools? Okay, good. The available statistic tool. So the HOWTO percentage. Okay, good. HOWTO confidence level that you use is 95%. Okay, thank you, Najuna, Dinesh, Hafiz, Rizal, Nizam. Yes, good. That means you this is Najmi juga. Okay, good. So sekarang you clear, so 95% is actually content most normally data. Normal data. Okay, the normal data, and the red area on the left hand side is to make yourself humble sikit lah, humble for not so that you can say you are not 100% confident, but you still allow. It's not talking about the confidence, but it's actually you still allow some error to your data collection. Okay. The error could be many things. Okay, so we will see that when you are doing your assignment, you can see some of your data collection probably give you an error lah. Okay, so this is interval estimate. Okay, so for today, okay, so for today we are going to do some further procedure. Okay, when we are trying to find the confidence interval, okay, for things that are for a data that we assume is actually normally distributed. See how I classify, okay, the content of this subject. Okay, first we start with all the data is normally distributed. Okay, and type of data, the sampling of the data can be you want to sampling data of in the mean, or you want to sampling the data in terms of the proportion. Okay, the idea of take a sample because you want to estimate the population. Okay, now we move to in the confidence interval. When we talk about confidence of normally distributed, now it is actually normally distributed. Later in the following chapter, we will also consider a data which is not normally distributed. So hold on, if you have a doubt that what if the data is not normally distributed, we will come to that part later. Okay, but for today we focus first. Okay, assume that the sampling that we have is to predict, okay, to estimate the confidence interval for normally distributed population mean. Okay, and there are 4 cases here. Okay, they split into 4 cases. Okay, because it depends back on the sample size of your data. Okay, again the clear cut to determine the sample size is either you have a very large number of sample, or it could be your study enable you to get a very large of data, so it's just a very small sample of data. So anything that is less than 30 is called small sample of data lah. Okay, one thing you want to estimate the population mean. Okay, there are a situation that this one is the population variance, remember? Okay, sigma squared is population variance. So there are 2 categories of population variance. It's either the population variance is given based on maybe previous data, or is you have no clue. You just only have a sample. Okay, you want to estimate the population mean. Okay, so that's why they split into these 4 cases category. Depends on the sample size. Okay, and also depends on whether the variance is known. Population variance, population is known here, can be given or not given. Okay, a case for a given may be based on previous data. Okay, or it could be there is a common commonly known of the variance of the data. But maybe this year you are doing another sample, you want to prove that whether that is actually the correct population mean, whether your design, whether the machine is still producing the same same output, the same result, okay, to meet the population mean estimate. Okay, so let's do this one. Okay, apa lah? Apa ni? Okay. Okay. Yeah. Okay. This set of question, okay, maybe we just go on surface first, to get to know whether the variance is actually known or unknown, Okay, we go for the first one. Okay, given a sample with a sample size of 20, okay, sample mean of 25, okay, and also sample standard deviation of 5. Find 95% confidence interval for the mean, assuming an approximately normal distribution. Okay, maybe kena baca lagi lah. As always, what I encourage you is actually at least read 3 times before you can extract all the important important information to before you go for the solution. Okay, so this one, okay, maybe we start at the bottom. So we are actually asking for question number 1. What is it, a small or large sample? Okay, and then whether the variance is known or unknown based on the statement given in the first question. Given a sample, for the first question, the sample size is 20. They just said they have the sample mean, sample standard deviation, and then they ask us to find 95% confidence interval for the mean, assuming approximately normal distributed. Fitness said this is actually for the large sample and unknown variance. Anyone want to support Fitness answer, or you want to give, you have a different answer from Fitness? For question number, we go for question number 1 first. How we know whether it's actually a large sample or small sample size? Okay, I think I have to go back this one. Okay. In determining the confidence interval, okay, we have to know we are dealing with in which cases kan. Okay, whether it's actually large sample or small sample. A large sample is any sample size that is greater or equal than 30. Anything that is actually less than 30 sample size is under small sample. Okay, and the variance, okay, this is actually what guys, this is population variance. Okay, we're going to see each of this question, okay, and we want to determine whether it's actually known or unknown population variance. Okay, so that's why we go for this example. Okay, we won't solve yet. Okay, we just want to address in which cases for the question number 1. For the question number 1, so the n is actually n is small, okay, and they didn't say anything about population variance. They just here in the information, we only have information of sample standard deviation. Okay, sample standard deviation meaning that we only have S equal to 5. Okay, sample mean equal to 25. Okay, and n is equal to 20. So n equal to 20 is under a case of small sample. Okay, so Fitness, Vivian and Ashraf and the rest of you. Okay, so this is actually for a case that actually a small and also unknown population variance. This is small sample, and also the variance is unknown. Okay, clear for the first question? Okay, maybe we go for the second this one we haven't solved the how to find the confidence interval yet. We just want to understand first, okay, how to determine whether we are working on the case of a large or small sample, or the variance is actually known or unknown. Because different cases we are going to use different procedure. Okay, so that's why it's very important you master first the different about these two cases, these four cases. Okay, so let's move to question number 2 pula. Okay, the average zinc concentration recovered from a sample of measurement taken in 36 different locations in a river and is found to be 2.6 gram, okay, per milliliter. This is just a unit. Then we need to find 95% and 99% confidence interval for the mean zinc concentration level. Assume that the population standard deviation is 0.3 and the zinc concentration is normally distributed. How about number 2, guys? Is it a small, large, or large sample? Okay. Okay. Good. Yes. I see some progress in the answer, meaning that you are more confident now on determine the cases. Okay. Clearly, it's a large. How we know large? Because it's actually they said the average of the zinc is actually taken from the sample of 36 different locations. Good. And then the average of it is actually 2.6. Okay. So this is actually the mean. Okay. The number of sample and is actually greater than 30. Okay, and then here they assume this is the condition where where the population variance is actually known. Okay, because it's clearly stated here that this is actually assumed the standard deviation is 1. So this is actually the sigma is given. So when it's given, meaning that we can know. So we can so when it's actually given, so meaning that the variance can be known. Okay, so large and known, Ashraf. Okay, it's actually known variance. Okay, even though they give standard deviation population, but from the standard deviation, the sigma, okay, we can get the variance. Okay, are you guys clear up to question number 2? Up to example number 2? Ashraf, okay, do you know? So it's for this one, for the second one, the the population standard deviation is given, so it leads to the known variance of population. Okay. Okay, now let's try number 3. We won't go all, but let's go for number 3 pula. The contents of 7 similar container of sulfuric acid are this one, this one, this one, this one, this value, this value. Find 95% confidence interval for the mean content of all such container, assuming an approximately normal distributed. Okay, how about this one? Small, unknown. Okay, be careful about this one. They didn't say anything about sample. They just said the content of 7 similar container of sulfuric. But the trick here, okay, okay, Theo is giving small and it's actually unknown. But I want you to try to read again, because it's here it stated that for the mean contents of all such container, assuming approximately normal distributed. We actually have 1, 2, 3, 4, 5, 6, 7. Okay, 7 sample, and from this sample, when we use the tools of Excel, we can derive their sample mean. Okay, and remember, because we in this study they actually focus on estimate all of such container. Okay, based on these seven container value. For this one, is actually under a known also. We can actually get the known variance, okay, by based on these 7 the data of the container. Okay, so for this number 3, it's small, correct? It's a small sample. Okay, but it's actually we can measure also the standard deviation and the variance based on the 7 data. Because here the trick here is actually because the term word all here. So it's actually a study on population. Okay tak? Or you have any based on these 3 example? Are you clear? This one, so this one is a small, okay, small. Okay, but the standard deviation we can it is actually known because of this term all there. Meaning that it actually reflect to the population of the all data that you have. Okay, you can measure this using calculator or using the Excel. Okay, this is one example lah. Okay, are you okay or you want to go for the 4 and 5 and 6? Maybe we go for another one lah. Number 4. Okay, for number 4, okay, buat satu lagi number 4, and then why is it very important we read and we understand the context of our study, the data that we have. Okay, because different types, different cases will need us to use different procedure of in determine the confidence interval. Okay, nanti I tunjuk satu table yang very important. Okay, this one number 5, we go just number 4. There's a civil engineer that is actually collected data from one area of Wisconsin on the amount of salt in a ton units used to keep highway drivable during a storm. Kadang dia punya ayat tu memang saja dia bunga-bunga. Okay, so now let's focus. The amount of salt from n equal to 30 storm has a sample mean from here you can just sample mean of 1798.4 and the sample variance of this value, 60,000 value. Assuming the measurement to be normally distributed, construct the 95% confidence interval for the mean amount of star required for. Okay. I do have a problem. Not sure whether if n in the borderline between the large or sample, okay, just use this value. So anything that actually 30 and above is we can consider that as a large sample. Okay. So what is the lesson from this example? You have to very clear, okay, what whether the sample that you have is in the category of a large sample, anything the sample size that is actually greater than 30, or if you get a sample that is less than 30, automatically it's actually under a case of small sample. Then in determining the population variance, you have to very careful, okay, when the standard deviation of the population is actually given, okay, so meaning that it's actually you can determine the population variance known. Okay. Okay, good. Thank you, Vignesh, Ashraf, and Michael for the feedback and the rest of it. Okay, yang lain-lain okay ke? Walaupun you didn't put your answer, but I do hope you get how to extract from the data. Okay, I see some thumbs up. Good. Okay, so that's why in our first class, I keep remind yourself the importance of you understand the usage of the this notation. Okay, because and then how this actually how the notation is actually reflecting on when you are doing the estimation and hypothesis and so on nanti. Okay. Okay, so let's move forward. Okay, first we from the question we know we have to divide that into different cases. Okay, why this is important? Okay, this especially in determining the confidence interval just now, because in a way for us to estimate the population, we need to know what are the procedure involved. Because for a large sample, we probably use different procedure, and different procedure will actually lead you to refer to whether normal distribution table or T distribution table. Okay, last Friday we have seen how to read between the normal distribution table and also how to read from the T distribution table. Okay, so this one previously when we are doing the last 2 semester online, okay, I specifically encourage my students to keep this slide, okay, to guide you to choose which procedure that will give you will help you to determine the correct confidence interval. Okay. Okay. Let's learn how to read from this table first. Okay. So this table is basically to summarize how we can compute the confidence interval for population mean. Okay. And it's split between a large sample. Okay. This on the left side you have a large sample. On the right side you have for the small sample. Okay. So, and then we know there are 4 cases. Okay, for the large sample is either the population variance is known or unknown, and for the small sample whether it's actually known or unknown. Okay, so when we know 4 cases involved, okay, the idea here is we want to find the confidence interval. Okay, we will move to until the last row, but let's move to by row. Okay, so the first row is to split into 4 different cases. Okay, the second row here, okay, you can see we are actually computing the standard error. Okay, this is the formula to compute the standard error. Okay, why is this important? Because it will help us to determine the maximum error. Okay, and then later we will use it to determine the confidence interval. Okay, uh, okay. You can see here if the population variance is known, definitely we can get the standard deviation error. Okay, if it is actually the population variance is known, okay, square root of that will give you the standard deviation, that will give you the standard error. Okay, and n is just an number of sample depend on for the large sample. Okay, but if it's actually unknown, we need to use the sample standard deviation. Okay, and then the rest of it. Same goes for if you are dealing with a small sample and the population variance is unknown, you can directly use the population standard deviation to compute the standard error. But if it's actually not given or unknown, you can use from the sample standard deviation. So far clear up to this row? Okay. Now let's move. Good. Okay. So you will see in this third row, everyone is actually having this Z alpha over 2, Z over 2, Z over 2, but for this one, they use T. Okay, what is this Z, and T refer to? This is actually reflect back on the critical point. Okay, last week we know that this critical point will determine the separation between the shaded area and the unshaded area of your distribution table lah, data distribution table. I suppose I can. So, but you can see here. Okay, we will refer back to the table later. Okay, but you can see for the large sample, clearly we directly use normal distribution table because of the Z. Okay, normal distribution table. I think I should write. That is when you use. Okay. So when you use Z here, meaning you are using for normal distribution. You can add your some normal distribution when you use Z. Okay. Okay. But if you see that C, meaning that you have to use T distribution. T distribution table. Okay, for this one, Z, meaning that we have to refer to normal distribution table. Okay, so because this one is the critical value that split between the shaded area and the unshaded area of your data. Okay, the one that actually will determine the separator between the confidence, the region of confidence and the error that we allow in our data sampling. Okay, in the maximum error row, you can see that there's no problem. We can straight away use normal distribution. Okay, the only difference is actually one for the unknown, we use the sample standard deviation. Okay, but we have to be careful a bit when we have a small sample of data. Okay, because in a small sample of data, you can see that if the population is given or known, we can still use the normal distribution. However, if we have a small sample of data and the population pula unknown is not given, okay, so we already give as we already use as in our standard error. So the value on to determine the maximum error, we have to refer to the t distribution. Okay, so this is the difference between the four case within these four cases. Okay, in terms of how to determine the maximum error. Okay, I'm hoping that you are clear between these four cases. Now we are finding the confidence interval plug. Okay, the confidence interval. As you can see, all of the confidence interval is actually based on the sampling mean. Sampling mean, if you remember, when we talk about confidence interval, okay, so we are actually allowed from the average of this data, okay, and we have the critical, okay, the critical point, which actually, if you are referring to this normal distribution, okay, on the left side, that's why we have negative, and also the positive side. Okay, and which is multiplied with your standard error. Okay, same goes for the live sample. It just the difference is only in terms of number sampling a sample of a standard deviation, as is a standard deviation, sample standard deviation. And for the small sample pun sama. Okay, you just because x is the average of the data, and left and right is to determine the interval between the two data. Okay, so how to determine this alpha is actually based on the standard deviation or significant level that is actually given in the statement of your data. Okay, so I'm hoping that you clear how to read from this table. Okay, um, I'm I feel that having this table will hopefully help you to structure your understanding on which table should I refer to, okay, when I have this certain of data. Okay, clear this one, this table? Okay, sila nampak cahaya-cahaya yang ni. Okay, thank you. The few things. Okay, now let's work on uh on the part that where we need to do a solution, numerical solution, or in finding this. Okay, so we go for, okay, so now let's go for the, so that's why we have four different procedure for four different cases. Okay, we are the one that actually supposedly to know the difference between the cases. Okay, let's use this example. Yang sepatutnya highlight. Lah. Okay, in this example, okay, example ni dah siap dengan solution ni, never mind. We can at least we are confident on how to extract all the important message, important information from this from the statement. Okay, so standard is actually stated, okay, from a sample, okay, sample size dia 20, okay, you are given a sample mean 25 and standard deviation of 5. Now we need to find the 95% confidence interval for the mean, okay, assuming an approximately normal distribution. So ni tadi from the example, the list of questions from the example that we discussed earlier. During that time, we just want to know whether this is actually a small or large sample, and whether the population variance is given or not given, or known or unknown. So based on this, we have agreed that this is the example where you actually have a small sample, and also unknown variance. Okay, small sample and unknown variance. we know that it's actually because based on this data, okay, size of 20, okay, and then we only have the sample standard deviation, okay, so meaning that unknown population variance, okay, small sample unknown population variance. So when we have this kind of thing, to determine the 95% confidence interval, okay, we have to extract what is actually the alpha here is actually the significant level, okay, and then why we have to divide by 2, because we allow the interval have some error on the left side and also some error on the right side, okay. That if you want to draw, okay, if you want to draw in the graphical expression, okay, you probably have data, okay, and you are confident by 95% of the data, okay. So this is the error, the standard error that you allow. So it leaves you by 5%. So 5% on the left side divide by 2, so you have 2.5% on the left side. On the right side is also 2.5%. Okay, and we need to find the critical value because of this is a small sample and unknown population. So we use T. We refer to the T distribution instead. Okay, T distribution table. Okay, what is T distribution table? I put it here. Okay, that's T distribution table. This is what we learned last week. Okay, what are the value that we should refer to? Which column, which row that we need to refer to? So in the T distribution table, you notice that the subscript of the data require us to find alpha over 2. Okay, so what is alpha? Alpha 0.05. Okay, the significant level is 0.05. Okay, alpha over 2, you just divide the significant level by 2, so 0.025. Okay, and here is 20, 20 minus 1, 19, 19, and then this, how we get 2.093, meaning that we refer to the column, tak boleh klik. Tak boleh klik. Tak bagi. Okay, kalau tak boleh klik, let's verify our result using this the table. So we ada mana? Okay. So we are looking for T 0.05, A 0.025 on the third column, and then go to the row 19. So yes, correct, we get 2.093. But if you remember last time in our session during the tutorial, I do also introduce to you that you can also use Excel to help you to speed up your searching on this on the value of normal distribution. So there's also a command on when you want to find the T distribution. Okay, siapa rajin boleh ni, or else you just maybe you use a conventional way where we refer to the table. Okay, so what you do, okay guys, so what you do with these two things, okay, with this value is because we want to determine the interval of what? Interval of the population, okay, population data, population mean. Okay, for this example is population mean. So that's why what you do, okay, the given mean is 25. So in the middle data is 25. So the interval, okay, of the mean is plus minus, okay, the standard error, okay, the value of the standard error, which is actually derived by the sample standard deviation 5, okay, divide by square root of number of samples 20, okay, multiply with the critical value of the data that you based on the small sample and unknown population mean. So 35 plus minus 2.34. I think kalau nak, let me check. What is actually, if we go for more accurate value, 5 divided by square root of 20 multiply with 2.093. Oh yeah, dia punya, yeah, up to 4 is actually you get 2.300. Okay, so that's why in the end, up to 4 decimal places, you will see that the interval, okay, the interval is from 22.66 until 27.34. So this is the confidence interval, okay, of the based on the sample. This is the confidence interval for the population mean, okay, under a 95% confidence interval, until 95% confidence interval. This is the value of the interval of the population. Of the population mean. This is population mean. The population mean have the confidence interval of 95%. Okay dah? Okay, I want you guys to get some idea first lah sebab ni kan. Okay, kita buat satu exercise. Okay, we do the exercise. I tak tahu saya start dengan example 3.3C first. Tak apalah. Okay, we will use this exercise pula, but I'm going to use the tablet. Okay, the question is given by this: the average zinc size. Okay, the average zinc concentration recovered. Sorry, tadi network problem. I'm not sure. Maybe some of you have to rejoin back due to the network problem just now. Okay, we're going to use this example to discuss. Okay, and I'm going to change to use the tablet. Okay, as we have seen that this is actually unknown. Okay, unknown. It's actually a known population variance because we have the value of population standard deviation. Okay, we just have to find two different confidence interval. Okay, one is actually 95%, another one is 99%. And another thing is we have the number of samples is 36, and from this give us the average mean of this is 2.6. Okay, so let's do the solution for this one. Okay, we're going to do for exercise 2.6. Sekejap, Okay, get ready with pen and pencil. Pelik. Oh. Sekejap. Whiteboard. Tak clear. Yeah. Pressure dulu semua and is 36. So because of this is known, we know that this is the population standard deviation is given, meaning that we can find the population variance. Okay, meaning that the population variance is known. And then it's actually a large sample. So we are referring to large sample and this one is known. Okay, but we're going to use this formula for two different interval. One is 95% and the other one is 99% kan, according to this. Okay, so we're going to do this one. We're going to use this formula. So I change this tablet. Share screen. Sangat screen. Net screen. Okay. So from the sample of 36D, you have the mean of this is actually giving us 2.6. Okay. And then because we have this population standard deviation, which is actually 0.3. This mean we know that this is actually unknown. Unknown. This is the variance is known. Okay. And also we have a large sample size. Okay, because n is greater than 8. We are going to use the first cases. We are going to determine the confidence interval. One is actually using 95%. Okay, another one is actually using 99%. Okay, we see the difference. Okay, so in a way for us to establish this, okay, we need to find the standard error, the critical value, and then from that, we can get the maximum error, so that in the end we can establish the confidence interval. Okay, the confidence interval is from plus minus the critical value alpha over 2 but minus by the standard deviation over n. Okay, so one thing's for sure, we need to find the alpha for both cases. Okay, because the alpha for both cases, which is the significant value. So we need to find the confidence interval, CI confidence interval, okay, using the mean, okay, and then but we need to find the critical value. Okay, to determine the critical value, we need to find first what is actually the alpha. Okay, based on the confidence interval, 95%, so the alpha is actually 0.05. The value of alpha must be less than 1 tau guys. Okay. And for this one, for number 2, the value of alpha is 0.01. Clear the difference between these two? So the significant level, is actually taking the value actually less than 1. Okay. And then a coefficient for this one, the confidence coefficient is 5%. Okay. And then 5%, and that is give you the significant alpha value is 0.05. Okay. So for alpha over 2, we just split into 2. D1 0.25. The one is alpha over 2 is 0.005. Okay. Okay. And then we need to find the critical value that contain the value of alpha over 2, 0.025. Okay. How to determine this? We can find from the table of this normal distribution table, because we refer to the Z. Okay, another one is 0.00. Okay. So Z 0.025, meaning that we are searching for the data, the value of the value inside the table, which is 0.025. I think we have done this last week. Can anyone share what is the value of Z alpha 0.005? We done this before. What is the critical value for 0.025? You can check your answer dekat chatbox, dekat what is Z for 0.025 and what is Z for 0.005. How to determine this? Okay, thank you. You give the answer for 95%. Okay, another one is actually for, so the answer from Theo is for 95%, and for the 99%, we have done this last check out last week notes. So the critical value is 1.96. Value for the critical value for 99%. I think I've in the notes, guys. Habis cuba share 0.05. Or you can also use your Excel. But for Excel, you have to use command inverse of normal distribution function. Tak apa, we hold on hold first. Maybe you tengah cari dekat ni kan. So what you do with all this value, okay, to get the confidence interval plus minus of Z 0.025 multiply with sigma. Okay, the sigma for this is 0.3. Okay, and the square root of n. So the n for this one, tadi n adalah 36. So the confidence interval, okay, will actually give you, okay, the mean for this case is given, the mean tadi berapa? Oh, 2.6, sorry. So 2.6 is the mean. So 2.6. So the plus minus here 1.96. Carilah kita punya 1.96 divided by square root of 56. Divided by 6 lah. Square root of 0.098. This is for 95%. Okay, thank you once again, Theo. Yes, this is actually, nanti kita tengok how you get 5.6. We just count again totally. So basically for the critical interval Ci, in plus minus, now Z 0.005, 0.3, square root of 36. So this one for 99%. Also 2.6. We will see the difference between these two. 2.575 times 0.3 divided by 6. So take 0.1288. Please check with your calculator as well. To get the feeling on how you determine the confidence interval. So finally, the confidence interval, okay, for the left side is you use 2.6, okay, minus, okay, the set is minus 2.6 minus 0.098. So you get 2.502. And for the right side, 2.6 plus 0.098, 2.698 Same goes. That for this one. For the plus side, you ambil okay. Always the negative because less value than the mean up to the greater value than the mean, the population mean. So same goes with this one. So the confidence interval is 2.6 plus 0.288, 2.7288, 2.6 minus 2.4712. Buat tahu guys. Okay. Okay, how many of you get the same answer? Show some reaction. Good, Fardin. So one from Fardin. I believe you also get the same. Good, Shukri pun I nampak. Okay. Good so you nampak Okay, so now I want to show in the form of image lah how this works. This sebenarnya konsep dia sama je. Same concept. You have taken from that sample and then you just want to find the mean, okay, from the sample, the mean, then from the sample mean, just now you get 2.6, okay, 0.6 of the mean, and basically for the first, if for 95% of the data is stated between 2.502 until 2.698. So somewhere here. Okay. And then for 99%, so the data is 2.4712 until 2.728. So you can see the region of this data and how this actually reflects back to the confidence level that you have. Okay. So indirectly, you are trying to say that I am 95% confident that the interval of the data for the mean of 2.6, okay, is between 2.502 up to 2.698, okay, for 95. Okay, for 95. So for 95% of the data, 95%. For the 95%, I'm using red kan. Okay. For the 95% of the data is within this 2.502 up to 2.698. Okay. Whereas for, if I can increase the data and say that 99%, okay, from the mean of the random sample data. Okay. So itulah benarnya. This is how you determine the confidence interval. Okay. The break sekejap. We'll share with you the I will share with you the mana? I share with you the password for attendance. This we already past 1 hour. Mana? Belum share. So the password today. Today Friday, the first month of April. Yeah, I'm strong. So hopefully this month will start with a strong health, strong in mind, strong in spiritual, strong in vision, vision. Okay, so you can share also the student attendance in the chat box. This is what we learn, except the emoji. I am strong. So I believe you can also do for this one. Okay, exercise this one. Just follow the steps as that. Understand. I suka ada BEKM, but you can faham. If only I also the first one that actually help you to structure the content very well lah. Kalau I tu macam pagi tu tak betul ke apa, nanti kesian juga kat you guys. So I believe you guys can continue with the remaining example if you really understand the two exercise that we discussed earlier. Okay, so that we can move to the confidence interval untuk proportion pula. It's actually the same thing, kan? Dah masuk dah, masuk. We're going to next. We're going to finish this session with how to determine the confidence interval. The same thing, but now the two examples we discussed about the population mean. Okay, but do remember, other than population mean, we also have the we also want to estimate the population proportion. Okay. So thank you. And okay. Okay. Terima kasih. Okay. So kita habiskan ni. Basically the same thing then. Okay. If you understand the structure, okay, how the structure works, in determine the confidence interval, okay, where we need to know whether we are working on a sample size, a large sample of size or small sample size, okay, or whether we are given the variance or the variance is unknown. Okay, we know there are certain procedure that we need to follow. Okay, if we replicate that procedure into the into finding into estimating the population proportion, okay, we also can conclude, okay, that we need to know whether we should refer to the sample standard deviation or for the unknown standard deviation, okay, or unknown variance, or we are using the standard deviation population if the variance is given or not. Okay, so I dah macam pelik-pelik. Okay, we try to finish our this. Okay, so what are the important things in what is difference and what is the similarity and what is actually the difference? Okay, when we talk about confidence interval, because we are still following the same procedure, okay, confidence interval, but in the what is actually the difference in the population proportion. Okay, by now I hope that you but that you understand. Okay, when we talk about proportion, okay, we are not we can't find the mean, we can't find the average value of our sample data. Okay, but we only know, okay, the success ratio, okay, of our sample over the total sample of that we have. Okay, so that's why in proportion, when we talk about proportion, we have the ratio of the data. Okay, and the ratio is normally can be represented in the percentage form. Okay, which is actually derived from the success rate of the success of the variable over the number of samples that we have. Okay, we have seen this before in chapter 2. Okay, to differentiate between the mean and the mean and also the variance of our population proportion. Okay, so in the population proportion, the sample standard deviation, okay, is denoted by this value. It's just standard deviation of a proportion, which is actually taking the value of P and Q over N. So what is Q? Q is 1 minus P. We have discussed this before. So if P is some success rate over the number of samples, so the Q here is 1 minus of this value, 1 over P. Okay. So to get the standard deviation of proportion is actually standard deviation is square root of the variance lah kan. So the variance is actually P Q over N, because it is actually considered for any normal distributed of proportion, the mean is actually taking the P value, P hat value, whilst the variance is actually taking the P Q over N of the data. Okay, you can watch again our previous or just flip through the lecture notes from the chapter 2. Okay, the difference between this. Where one is actually taking the value of the mean, one is actually the variance. So indirectly, okay, the confidence in interval similarity, we need to know what is the center, okay, the center of the data, which is taking the proportion, the sample proportion value, and then we also need the critical value. Okay, the critical value have to match whether we are working on the large sample, the 4 cases just now, okay, and also this is the standard error that we allow in our sampling lah, to determine the confidence interval. Okay, so by having this and this is also just repetition based on the previous lesson, in a way for us to know that the sample size that we have when any study involving a proportion, n must be significantly large if the n times the proportion value is greater than 5. Okay, so it's considered large lah. Okay, I'm sure they have a table. Okay lah. We discussed this one. Okay, example 3D. Okay, I think we can discuss this further in the next session lah. We just choose this, get the idea, because the idea, I believe once you understand the two example that we discussed earlier, and then expand to this proportion, you at least you have some idea on how to proceed on in determining the confidence interval lah. Okay, so for this one, you will see, okay, if you read the question, they didn't mention anything about mean, they didn't mention about standard deviation and so on, but we can actually get an idea from that where this actually involving sampling proportion. Okay, so in a random sample of 600 undergraduate students in Malaysia, it is found 98% students are direct entry from diploma studies. Okay, so let's construct a 99.9% confidence interval for the actual proportion of the direct entry diploma based on the undergraduate students in Malaysia. So clearly there's no mean of sample, no standard deviation of sample. Okay, so this is directly, we know it involves a proportion. Proportion of what? Proportion of what is the success here that we are looking for? Confidence interval of the direct entry student. Okay, direct entry, X is the direct entry student. So what is the number of direct entry student? 98 here. So 98 over the total samples of 600, and okay, so this bring you to this figure of the proportion, okay, which is actually determine the mean of the proportion sampling. Okay, so you can estimate whether it's actually considered a significant large. So by multiply the value of P with N, so clearly it's larger than 5. Okay, so to determine the confidence interval, okay, we have to find what is alpha. Okay, what alpha is actually the significant level. Ada soalan ke? Significant level. Ada soalan ke tadi? Kan okay. So 99.9% is the confidence interval that we are looking for. So we need to find what is alpha. Okay, alpha is taking the significant level. Okay, the confidence coefficient. Okay, again must be less than 1. So this is alpha. But to determine the critical value, we have to find the Z alpha over 2. That's it lah. F/2. So that brings us to find what is the critical value having a probability of 0.0005, which is 3.26 here. Okay. Again, kita boleh tengok daripada, we can see from the table lah. Okay, 0.005. Okay, 0.005 meaning that we are looking for something inside of this table. 0.000555555. Yeah, somewhere here. Okay, 0.05 double zero kan? Oh, 30. So 30, oh here. Value. So this value, this one, and this column, 30. That's why we get 3.28. Okay, 3.28. Kenapa dia pakai 3.9? Tak apa, it's supposed to be 3.28 based on the table. Based on the table, 3 ke? Saya tengok 3.2. Oh, because it's the value is very, very small. So 3.8, 3.29. So we go for the far to the left value. Okay, so that's why they choose 3.29 here. Okay, 3.29. I think if you use Excel, you get a more precise answer lah. Okay, but for the purpose of understanding where this 3.9 coming from, they choose a value of in the Z, which is far to the left. Okay, because they want to far to the left and far to the right. Okay, so that's why the critical value is choosing the highest one, which is 3.29. Okay, so you get your standard error. Okay, multiply with this value. Where is this value coming from? This is actually coming from, remember just now you have the square root of 0.166 1633, okay, divide by apa, 1 minus 0.1633, you get 0.83, 0.8397. Okay, then you divide by, and your n is 600. So that brings you to this value. Okay, P 0.93, kira je 163, multiply with this, and then divide by 600, and then you square root. So you get the answer here ke? Value lain ni. Oh, and then you multiply pula dengan 2.29. Yes. Then you multiply with 3.29. Okay, because it must become together with 2. Okay, so you get the maximum error. So therefore, you are 99.9% confidence that there is the interval, okay, for the proportion is from 0.1137 to 0.2129 of a student with that from a direct entry diploma student studies. Okay lah. Dah 9:34. Do you want another example or you think enough for today? You can give your comment or reaction in the chat box. Tak nak ambil risiko. What is your confidence level about this topic? Okay, Ashraf have 95% confidence level about this topic. Anyone is slightly higher than Ashraf confidence level? What is your significant level about after you go through this today lesson? Korang agree dengan Ashraf punya confidence level? Interval. I let you to continue the remaining of this one. Okay, as usual, please have some effort, some action on understanding this topic. Okay, if you just listen to me, maybe you can get maybe you can get 80% of what is discussed. But until you do it, until you explore by yourself, until you really go through all the exercise, you will actually enhance your confidence level lah to 95%. The 5% error is human error lah. We can use that as human error. Okay, but at least please expand your confidence interval for this topic, because this topic is very significant. We're going to use it over and over again until 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 end of this course, and then later on you can really apply it for your engineering fields. Okay. Yeah, we have a lot of exercise here that I want you to explore, okay, by yourself. Maybe we continue next week. Okay, make sure you sign the attendance. Let's see how many of you are online. So I think we can end this session. Stop recording for this time.